All right, this is what we're gonna do. We're gonna start off with an EOC breakdown. We're a little bit behind, but we'll catch up pretty quick. We'll do a little bit of a geometry review, or algebra review for a couple big points. Then we're gonna go into statistics, circles, probability, like that. So let's look at the EOC. This is how many questions you're gonna take. Now, I heard a rumor that the EOC ELA today, you only had 3 multiple choice questions. Does that sound right? All right, guess what? You're taking a whole lot of questions. You're going to be doing 73 math questions when you take the EOC geometry on Monday and Tuesday. 73. And guess the worst part of it? Of those 73, only 58 actually count toward your score. So you're going to be doing questions that will not help or hurt your score, and the worst part of it is, they're not even telling you which questions count and which questions don't count. You have to believe every single question there. Okay? From there, at the top, CR means constructed response. So basically speaking, that means things like the CR means it's counted. The selected response means multiple choice. So you're going to start off by having multiple choice questions. Then there's also those technology enhanced. So I think there might be a video that shows you that piece of it. I'm not exactly sure. But I did go through that with some of my students. So you might have the technology enhanced questions. That's like drag and drop, rotate a transformation, constructed response. Okay, here's the great news about constructed response. It is not ELA. Constructed response is just get to the point. Don't write a paragraph. You don't have to say that trig represents Pythagoras and the formula is this. Like, they don't want to know this. These people who are grading your stuff is grading tons of information. So make their life easy, just get to the point. If it says what's the angle measure and the answer is 40, say 40. Like, don't say the angle and triangle ABC. Like, you're not going to get more points by saying that if they just want to know. The only time they want more than a number is if it's sentences. And for sentences, or when it says explain, then you're going to write sentences. But guess what? They don't need an introductory sentence. They don't need a complete sentence. They just want to know, tell me what you did. So don't overwork it for no reason. Okay, next. This is how the breakdown is, and we're going to kind of spend our time in this amount. You're going to have 35% of the test is on congruence and similarity. That means transformations, that means proofs, that means side angle side, dilation, scale factor. 15% is on circles, specifically like interior angles, exterior angles, 2 chords interacting, especially this thing, and you're going to repeat it after me because I need you to know it. I need everyone to tell me all circles are similar. Let's go, repeat it 3 times, everyone. All circles are similar. Again, all circles are similar. One more time. All circles are similar. You probably just got a free question on your EOC. Knowing that all circles are similar is a fundamental geometry concept. So if they have questions about, tell me about this circle and this circle, you'll know that all circles are similar, no matter what they look like. Equations and measurement, that is things like, equation of a circle, x squared, x minus h squared, y minus k squared. That's things like midpoint formula, distance formula, those types of things all fit into there, as well as trig. Statistics and probability is essentially statistics and probability. A couple things for multi-step equations. Don't forget to carry or to when you distribute rather. Don't forget that when you distribute, you need to make sure. I don't know why that happened. You need to make sure that you go all the way across. I'm going to have to refocus because that's not working. You're going to have to make sure that if you distribute, you're going to do -3 times 4, -3 times 3. Some kids, if they forget algebra from last year, they start thinking they're going to take this -3 all the way over here. That's not what happens. Don't forget that when you multiply, these are boundaries, and that keeps everything in one place. For proportions, unit matters. So example, like when you get to density, where it's like how many people are in a particular place, that kind of goes on from there. So we need to make sure when we do proportions that the things match up, the labels matter. Oh, look at this. What's the thing I said you had to memorize? All circles are similar. Fantastic. So let's look at this. What would be the transformation that would move this? This should be on your paper. What number is this on your page? Okay, so we're going to take about 30 seconds, and I want you to try to figure out what transformation happened for this to go. Two things. It's a dilation. I want to know what kind of dilation, what's the scale factor, and I want to know something else happened. If it was just a dilation, both of the circles would have the same center. Right, so figure it out. Dilation, translation, but a dilation by how many? And a translation by how many? Tell me what happened. All right, you got this. You can whisper to each other. This is small finger time if you're one of my kids. If you're not, I'm not going to explain it right now. 30 seconds, you got this. Hi. How can I help? I didn't get a paper. Does everyone have an orange paper? If not, please come up and get an orange paper. You will need it. Okay, what did y'all get? Yep, a translation and dilation, we know that, but what's the translation? What's the translation amount? Someone said -6, someone said right 6. Which one is it and why? Who's got which one is it and why? Awesome. It is +6. Why is it +6? It moves to the right. How did you know it moves to the right? What helped us out to figure that out? A to B. They are going to try to trick you. Excuse me, ma'am, honey, can you sit on the other side? That's not an acceptable seat. Okay, A to B. So because it's A to B, that's why we knew it moved right. So it went right 6. What else happened? Down 2. Did anyone figure out the scale factor? 0.6? Well, look at circle A and look at circle B. Which one looks bigger? B, so if it was 0.6, wouldn't that be smaller? So what is it? Try again. Who else has got a different answer? Because that's way off. 2? Ooh, 1.5. How did you get 1.5? Okay, what's the radius for B? 3. What's the radius for A? 2. Write this down if you don't know. Anytime you do scale factor, it's always going to be the image over the pre-image, or the new shape over the old shape. So I like to say, oh no, new over old. One of my students says it's like when you want to paint your bedroom, you put new paint over the old paint. So you can think of it that way too. But it's new over old. Okay, I'm trying to see why this is not pulling up how I want it to. Hey, I think we might be able to be in the mud. Okay, next question. All right, next, here we have rounding. I talked about this in another video. If you stink at rounding, you should look, because the EOC is famous for giving you 2 answers. One that's a little bit up and one that's a little bit down. So you might get a question wrong because you don't remember how to round. If you don't remember how to round, what you're going to end up having to do is you're going to have to figure out, again, my pen is not working. I get an orange light. What you're going to have to do for this is you're going to have to look at, if it says to the thousands place is what we care about. So we look at the point next to it. So if you don't remember how to round, that's definitely something that you should look up online. Also, simplifying fractions. You will probably have a question where you have to simplify fractions in your head. So remember, the first part of the EOC, you do not get to use a calculator. So because you don't get to use a calculator, because you don't get to use a calculator, you will have to simplify the fractions in your head. So basically, all you're doing is you're looking at what number matches up. So in this case, we know that 24 and 40 both have 2 in it. So it could reduce by 2. But then you'd also start to reduce 12 and 20. So that's another thing that you're going to want to pay attention to. All right, let's look at probability. Everyone, let's give a round of applause to Mr. McCurley. You got yellow. I didn't even say that.
What do you want? What color you want?
Anything. I couldn't even get the mouse to move. Thank you. Awesome. Thank you so much.
It's on red.
That works. McCurley, our hero, man. Woo! Okay, so, and everyone, Mr. McCurley is the one who taught me about this device, so that's another A+ for him. Okay, so here we have, this is where you're going to be looking on the formula sheet. Okay, if we go down to this next one, let's look at this, Venn diagrams. If you don't know how to do this, take a picture of the screen right now. Okay? You should know how to do Venn diagrams. Ooh, I apologize. I should have stopped us earlier. That's my fault. I'll wait. 3, 2, 1. Thank you. So when we do Venn diagrams, we have to remember the difference between A and A complement. When it comes to A complement, that means everything else that's not in A. So for example, if I want in this room all the people under 18, who would probably be the people who would be the complement of that? Yeah, anyone over 18, right? Myself, Curly, the teachers in the back. That's it. Mrs. Peace, I think she describes it as a complement is everything that gets put together that makes it complete. Complement, complete. I look at it as everything that's not in that particular system. Okay, next, some probability tips. When you get to U, think of union. Union. So right here, the U, right here, that means union. So that means that it's together. So that's like myself. One of my students is making a poor choice right now with another student. That means myself and my partner, we get together. Our union would be all of our stuff put together in the same apartment. That's union. Intersection is like, y'all know that mess of a highway that they're building over there with Phoenix in 78, all that construction. The intersection is where those two streets meet. That's the overlap. Okay, so that's intersection. We have A, but not B, in subsets. I'm not going to spend too much time on that. Next. Let's look at conditional probability. We're going to get into the text in a second. You're going to start working on your by your own. When you get to conditional, this is the given. Everyone say given. Given. Whenever you have a given, you're definitely going to be dividing. So you might need to write that down. Also, when you have a given, you're looking at what two things do they have in the same, divided by a single thing. So for example, the probability that I go, like you mentioned the same story because I've been using it this year. The probability I go to Cincinnati and the zoo, well, if I say given I go to Cincinnati, that means I'm going to divide by Cincinnati. If I say given that I go to the zoo, hi, that means I go to the zoo. You need some help? Okay. So that's kind of what the idea is. So given is conditional probability. So yay, let's get to your books. What page is this in your book? What number is it? Six. Excellent. Look at slide 6. So, kind of, who's got an idea how to do this problem? What is the probability that a randomly selected person surveyed has a job given that the person is younger than 18? Who has an idea about how to do this? How many people are younger than 18 in this survey? 265. That 265 is your denominator. Of the people who are younger than 18, how many of those people have a job? Excuse me, we're not giving out extra food. Put that food back. He got one, he's been here a minute. There was never food in the bag. All right, I mean, on our system, but I'm telling you, we're not giving out any extra food, not at 251. So, given is 265. How many total people were there who had a job? 20. So your answer is going to be 20 divided by 265. I intentionally didn't bring calculators. I'm going to give you that answer. That answer is 0.08. So what am I going to look at for the next one? It says, what's the probability that a person surveyed has a job given they're 18 or older? What's my denominator going to be? Anyone? Why do you have 679? They have to be 18 and older, so that's why that doesn't look like 679, but that's why 679. Okay? Given 679. What's my numerator going to be? It says that they have a job. 587. I did the math for you already. That's going to give you 0.86. Now, this is something that I honestly forgot and I had to look up today. So let's look at letter C. For letter C, it wants us, is having a job and being 18 years old independent events. This is what I completely forgot, and now I'm going to reteach you. So, what you need to know is that if something is independent, hint, write this down. If something is independent, basically what that means is the probability of you doing that given thing, this line means given, is the same as the probability if you didn't have to know what was given. So for example, for letter B, we said the probability that a person had a job given they were 18 or older was 0.86. So we have to figure out, okay, well, what's the probability of a person just having a job by itself? The probability of a person having a job. All we're going to do is, how many people have jobs all together? 607. 607 people have a job all together. How many total people are there? 944. So I did the math for you already. That gives me 0.64. Does 0.64 equal 0.86? No. So because of that, it's not independent. Write that down. Not independent. Because 0.64 does not equal 0.86, it's not independent. Next slide. Oh, hold up, Hal. I got you. What happened? So let me say that again. If we look here, we had already figured out what's the probability that a person has a job when they're 18. In order for us to do this problem, we had to say, okay, what's the probability that a person has a job? It doesn't matter how old they are. When we did that, we got this number. We got this number because we said 607 people have a job. There's 944 people altogether. So that gave us 0.64. In order for something to be independent, it means that both of these things have to be equal. Because 0.86 doesn't equal 0.64, that's why this is not independent. Let's look at this problem. This is one of the easiest ones, but let's take a look. Some of you missed this little teeny weeny line right here. What does this little line mean? Not. Fantastic. This little line means not. Okay? So here it says, in a particular state, the first character is always a letter and the last character is a number. V is anything that starts with a vowel. O is anything that's odd. We want to know what is V and not O. Take 15 seconds, talk to your neighbor, figure this one out.
I probably should see the black, huh? And you can go, like, you don't have to see the floor. I don't know what you were thinking. Ooh, that's that'll look better. Thank you. Yeah, that's good.
Okay, thank you. 3, 2, 1. What did y'all get for an answer? C. C is correct. Because it has to be a vowel, so it's not going to be D, and it's not going to be D, and then it says not an odd, oh! Whoa, I was wrong. It's A. It's A. Holy moly, nice job. You got that. Woo. I got that number. Nice job. It's A. All right, let's look at the next one. Here we've got independent. 3, 2, 1. Independent. I'm not going to do all these examples, but on your formula sheet, there is something that says the probability of A and B equals the probability of A times the probability of B. Now, I have a YouTube video that takes way more time on this, so don't stress if you don't get it right now, you'll just watch it again. Basically, what this formula says is that if you multiply these two numbers together, if it equals this number, then it's independent. So when I multiplied 0.25 times 0.25, I got, I'm pretty sure, yep, 0.625. Okay, so is 0.625 0.5? No, so it's not this one. When you multiply 0.08 times 0.4, you get 0.032. Does that equal 0.12? No. When you multiply 0.16 times 0.24, you get, trick question, 0.0384. Does that equal 0.32? No. So it's got to be the last one, and when you multiply it, you get this number. This is a formula on the formula sheet. I see 1, 2, 3, 2 of my people are my students, my former kids. Are you talking about? Okay, so basically, this is a formula on the formula sheet. So you should star this so you remember it later. Because if they ask you if something's independent, all you're going to do is multiply. We're a little bit behind, so I'm going to go quicker. Here's another one. This is another given. This is also on your formula sheet. Oh, excellent. Double A, can you grab the lights for me?
Oh,
got it, thanks. So here, what you're going to do is, this combination, you always put the combination on top divided by the single one. So here's a hint. When you do probability, your answer always has to be less than 1. Always. clear, 0.72 divided by 0.46, you would get a number bigger than, yes. Thank you. You would get a number bigger than 1, so you know it's wrong. When you type this in, you should get 0.638. And that's the answer. Here, again, we're not going to go over that one. We're going to skip it. I want to skip it. Let's go to circles because I want us to all be lined up. Okay, so everyone, we're going to do some notes on circles and transition because we're a little bit behind. Okay, here we go. So you should not have these sheets. These sheets are available to you from before, and most of this, I think, is on that crazy quick review sheet. Do not stand up now, but if you don't have the crazy quick review sheet, there's some left over by the A door. Okay. Central angle is at the center. That arc and that angle measure are the same. Thank you. Inscribed angle is arc to angle. When we do arc to angle, we divide by 2. I'll wait. Oh, you guys are doing the sign in? Appreciate it. Okay, thank you. Internal angles form an X. Because of that, we add the arcs and divide by 2. Exterior angles, you're going to do the big arc minus the little arc and divide. Here's a picture of the parts of the circle. Remember that a part of the circle, the chord goes out to Z. You saw a video 2 days ago with that. The diameter is also a chord. The diameter goes through the center of the circle. The point of tangency, okay, I did that on purpose, touches at one point. Okay, if you see anything you need, you can always take a picture. 3 things you need to know. 3, 2, 1. 3 things you need to know. The tangent will always touch the intersect the radius and form a right angle. We're going to see where this is going to come up. An inscribed angle that touches the diameter was always equal to 90 degrees. You also have a quadrilateral. The opposite angles are supplementary. Here's 2 more things about tangents. Again, they're perpendicular. This bottom picture you will definitely see on the EOC. It's a fundamental concept. If you have 2 tangents from the same point, they're equal, and we'll talk about that coming up. Here, we've got some segment relationships. I know I'm going fast. There is a whole video on circles. Whenever you have segment relationships, you have to remember things like part times part equals part times part. If you have 2 parallel chords, they form congruent arcs, which means these 2 arcs are the same. We did this on Monday. Here we talked about outside times the whole thing equals outside times the whole thing. And then again, we went over this on Monday. So that video is on the YouTube channel. The YouTube channel is EOCMathReview.com. If you didn't know that, write that down. EOCMathReview.com. 2 more things. A lot of kids struggle with the difference between arc length and area of a sector. I think of pie. So here I've got myself a cherry pie. The arc length is the crust of the pie. It's the outer crust. The area would be the inside of the pie where all the cherries are. So if it asks you for arc length, it's asking you for the crust. But if it's asking you for the area, then you know it's going to be the pie. So let's look at some questions. Everyone say hi to Coach. Excellent brain reset. 3, 2, 1. Raise your hand, don't say it out loud if you know right away how to do this problem. Because I want to know if I need to spend time on it. How many people would benefit with me going over it for 1 minute? I see more hands. Okay, so we've got 2 types of angles here. We have a central angle right here, and we know it's a central angle because the vertex is at the center. And then we have an inscribed angle right here, and it's inscribed because the point is on the circle. It tells us that the measure of arc PQ is 70. The reason why we know it's 70 degrees is because it tells us, and the reason why we know it's an arc is because there's a little arc right here. Well, if this is 70 degrees, that means the central angle has to be 70. If you remember the circles Snapchat I passed out and showed you, the central angle needs the center of attention, so it gets all the money, so it's the same, 77. The inscribed angle gets how much? Who knows? Half. So if this is 70, what's left here? 35. That problem is done. What's the relationship between the two? You could say POQ is twice the measure of PNQ. You could say PNQ is half the measure of POQ. Like, you can say how you want to say it, but that's pretty much what that problem is about. That's it. That's the answer. The answer to POQ is 70. The relationship is one of them is half the other. And then the measure is 35. Yeah. Okay, next. In this circle, we know this is tangent. Pay attention to this one. This is a good example of something you're going to see. Okay? So here, it's the same premise, but it takes it from a DOK1 to a DOK2. And this is how this is a DOK2. If you don't know what DOK is, that means I'm not your teacher, and that's fine. DOK level is how challenging a problem is. So in this circle is tangent to the circle. Because this says this is tangent, we know what? What happens when you have a tangent and a radius? What does it form? We talked about that. Right angle, a 90-degree angle. And it tells you AC is tangent. So what does that form? Another 90. So together we have 180. Then it says that point D lies on the circle. How does that help us? How does point D, this being 48, how does that help us? Ooh, we can find the arc. How can we find the arc? Who's got that? Multiply that by 2. I already did the math for you. That's 96. So if that's arc 96, how does that help me figure out the measure of angle A? What does that arc have to do with the center of O? It's the same. Why is it the same, Jaden? Why is it the same? Who's got it? Because it's a central angle. So this makes this 96. So how many degrees are in a quadrilateral? No, 180 is in a triangle. 360. Who has an idea about how I can solve the rest of this problem? Add them all up and then do what? What? I heard divide. Subtract from what? Excellent. So all you're going to do is you're going to add up. This 96 represents the arc. So I'm going to kind of erase it so we're not confused. I don't know why that happened so much. So you've got 90, 90, and 96. When you do the subtraction, I'm just going to tell you the answer so we don't keep spending time on it. You're going to end up getting 84. So you're going to get 360 minus 90, minus 90, minus 96, and you're going to be left with 84. And that's your answer. Okay? Excellent. Let's do the next one. Here. Oh my gosh, you need a second? All right, next one. Here we go. Why do you think they would take the time to tell us diameter? Why is that important? Central angle, that doesn't help us too much. You signed in? Right up there. Ladies in the red and blue. Why is the diameter important? How many degrees is the diameter? Thank you. Is that Shaylin's voice? Excellent. 180. Why is 180 important? What am I going to do now? Subtract it. Now what do I do? Is that my answer, 60 degrees, choice C? Why am I dividing it by 2? Woo-hoo, y'all are awesome. That is correct. Because ABC is an inscribed angle, I have to divide it by 2. Yep, that's perfect. So 60 divided by 2 gives me that 30 degrees. Why? What? That's fine. What do you mean? I divided by 2 because arc to angle you divide by 2. 60 divided by 2 is 30. Okay. Oh, so what happened is, we know that ABC was a diameter. We subtracted 120 because this arc is 120. That left 60 for this arc. Then we divided 60 by 2 to get this arc, which is 30. Oh, raise your hand if you're supposed to be going to band. Okay, can you take care of that for me? I have the passes right here. Okay, I was told originally that you could stay there till 3:30, but someone told me to leave at 3. Anyone know what's going on with that? 180 minus the 120 arc that we know. That left me 60 degrees left. And then I did divided by 2 to get the 30. Rewatch the video, I got you. Next, I want us to keep as much on the schedule as possible, so I'm going to go on. 3, 2, 1. My students are the ones talking now. They're going to fix that behavior. Here we have arc length. Arc length, I'm not going to do this problem. The main reason why I pulled it up. Who can look at this and say why I thought this is important to talk about? Look at the answers. What do the answers have that make us ask? The answers have pi. What happens if the answers have pi? Why is that an issue? Excellent. Excellent. Because the answers have pi in it, you do not use pi in the equation. So what you're going to do is right here, these answers have pi. So because of that, when I type it in the calculator, I am not typing pi in. That is not going to help me out. Okay, same thing here. It's the exact same reason. What else makes this tricky besides it being pi? Who sees the other trick? If it says area of the shaded region, what's the other trick that it can get you on? Excellent. The question is, why else is this a tricky problem besides that all the answers have pi in it? And Nick just told us, it wants the shaded, they're just jealous. They want the shaded region, so don't use the 65, use the 360. So we're going to take 360, subtract the 75, and that's going to give you the theta. And then now that you have the theta, when we plug it in, we'll plug in the 285 for theta, and we'll take out the pi. We won't put the pi into the equation. Okay? The answer to that problem, I'm not going to do all of it because I have a whole video on circles, but that answer to that problem is choice D. Okay, next. Here, what makes this tricky? First of all, everyone look at the problem. It says the spokes of a bicycle form 10 congruent central angles. The diameter is 18. What is the length to the nearest point 1 of the outer edge between 2 consecutive spokes? So, y, first of all, is an area of the sector or is it arc length? I hear 3 people. Arc length. Why is it arc length? Because it's the outside of the bicycle. Just like the pie crust is arc length, this is the outside of the bicycle. What's the other trick? There's another trick. Say it louder. Yes, another trick is they don't give you the angle measure. So you're going to have to take 360 and divide it by 10 to get the angle measure. What's the final trick? One more trick that they put in this equation, or this question. Go louder. Yay! It's the back. It gives you the diameter. So what do you have to do to get the radius? Yep, so what you can write down is 360 divided by 10 gives you 36 degrees for theta. Then you can write down that you have the diameter equals 18, so you know the radius equals 9 because 18 divided by 2 is 9. And then in there, that's where you're going to use the arc length. Now, what do you notice about the answer choices? They're all decimals. There's no pi. So in this case, you will type in pi in the calculator. We good so far? Okay, congruence and similarity. Transformations, you should know reflections, rotations, that stuff you should know already. If you don't know it, watch the YouTube videos. I have a whole YouTube video on there. Don't forget when you do y equals x or y equals negative x, that it flips. Okay, and you're going to have to count diagonally. Let's look at some questions. What number is this one? 20? Okay, so for number 20, what do you know what's wrong about the second picture? Something's wrong about the second picture. Who sees it? B is longer. Because B is longer, it is not a dilation. So it might say something like, is it similar? Is it congruent? In this case, you would say it's not.
Hi, friends over there?
Okay, so, and you can see how that is.
Anybody else is in band, go ahead and grab your stuff, go ahead and make your exit.
Excellent.
If you want to make sure that you get all the materials, you guys have this posted on YouTube. Make sure that you go to our channel, find it on there. But don't fret, we'll just have to do it at home. Okay, so if you're in band, go ahead and stand up or meet me in the back.
Miss Emmett.
Ms. Evans, I have a couple kids who have been banned that their stuff is in my room for 11 o'clock. Okay, so that is another thing to notice. Okay, for reflections again, I'm not going to do this problem, you can practice it, but basically pay attention to translations, reflecting, and then on the y equals x, you're going to count diagonally. Everyone pay attention to this one. Excuse me, no one should be talking right now. Thank you. All right. Who remembers from coming to transformation one, how do we find rotational symmetry? Who remembers what to do? Amari. Yes! Round of applause for Amari. What do we do? 360 divided by what? The number of sides. How many sides does this shape have? 6. So that tells us that every 60 degrees, we're going to get rotational symmetry. So you will get it at 60, 120, 180, 240, 300, and I'm not going to put 360 because it's like we didn't even turn it. Okay. Now, there's another type of symmetry. Anyone know the other type of symmetry this has? Yes! This has line symmetry. So the line symmetry means where can you fold it so it matches perfectly on top. So you can fold it here. You can fold it diagonally like this. You can fold it diagonally like this. Does anyone else see any other lines of symmetry? Through the points. Yeah? Oh, exactly. Straight across here. And then also from point to point. Vertice to vertice. Exactly. So look at all those types of symmetry and rotation that we can get to map on itself. Guess what? The EOC wants to trick you. So you're going to have to see, does it have rotational symmetry? Does it have line symmetry? Those are all the pieces you're going to be paying attention to when you do this. Okay? Now, real quick about what I've already told you, that only works if it's a regular pentagon. Guys, everyone give a round of applause to Mr. Bennett for helping get our room set up. We appreciate him. Thank you, Mr. Bennett. Appreciate it. So, that only works if it's a regular polygon. And what a regular polygon means, it means all the sides are the same. Okay? Next, let's look at dilations real quick. Dilation also fits in similarity and congruence. You're gonna get a brain break in like 3 questions. Okay, so for this one, what you look at is the pre-image and the image matched, and is it corresponding? And the way that it's corresponding is that the letters match up. So if we look here, see how this says AB, A prime, B prime? But then here it says D prime, F prime, and BC. Because these letters don't match up, it's not the right answer. Same thing here, BC, D prime, F prime, the letters don't match up, it's not the right answer. Here, we have AB, which is our pre-image, over our image. Here, we have our image over our pre-image. So for that reason, it doesn't match up. So our answer is choice B, and it's choice B because it's AB over A prime, B prime, and BC over B prime, C prime, and it goes to the pre-image, or the pre-image over the image, pre-image over the image. So, Miss Coach, we actually have a brain break for 7 minutes for them to get up and first of all. Next, here, let's look at dilations real quick. For the dilations, all you have to do is multiply. We're not going to do this entire problem. But see how this says 1.5? All you're going to do is take 0 times 1.5. Don't worry about that bottom one. That gives us 0. 1 times 1.5 is 1.5. So that's our new point. Here we have negative 3 times 3. When we multiply both of those by 1.5, we get negative 4.5 and positive 4.5. Here we multiply this by 1.5, we get 1.5. We multiply 3 by 1.5, we get 4.5. And then again, that gives us our triangle. Okay? And that's all dilations are. Just that simple. Okay? Which is always true. What's that thing I asked you, remember, about circles? All circles are similar. Well, this is why they're similar. When you, excuse me? When you do these dilations, because things get bigger and smaller, it's not going to be A. Because if you've ever taken a picture of yourself and zoomed in or zoomed out, it's not the same. The nose isn't the same when you zoom in or out. Here it says the length of the chord is always greater. That's not always the case because you can shrink a shape. Here it says the diameter is always greater. That's not the same because you can also shrink this shape. So this is the one you should start. I would highlight it. I would remember the sentence because you will probably see something like it. The ratio of the diameter to the circumference is the same for both. Okay, we're going to keep going real quick. Here, this one we've done already. I just want you to write this down. Whenever you have similar things, write down this, similar, dilation. You're going to write down sides proportional, and this is on that crazy review sheet. Proportional. And angles are the same. So they're going to try to trick you in this case, and they're going to say, oh, you have to multiply by 2/3 because the scale factor is 2/3. But that's not the case. Because sides are proportional, angles are the same. Let's say that 3 times, everyone. Sides proportional. Again, sides proportional. Last time, sides proportional. Here, hopefully you get a question like this. It's so ridiculous easy. It says parallel. Guess what? Because it says parallel, it means we can set up a proportion. So it wants to know the length of GE, which is here. Watch how easy this is. See this line? That's a reminder, just set up fractions. X divided by 3 equals 6 divided by 4. What do I do now? Who remembers from algebra? Thank you for not saying butterfly method. It is cross multiply. 4x equals 18. What do I do next? Divide by. Brilliant. X equals 4.5. Okay. Next, just know this one. If you have these two lines are parallel, if I were to connect these medians here, It creates congruent parts. That's it. Nothing too big. It's called the mid-segment. I'm not going to really talk constructions. I am going to ask you, please memorize these pictures. Please memorize that this picture bisects an angle. Please memorize this picture is a perpendicular bisector. Okay, you can definitely read it on your own, but I do want you to memorize those two. Here's another example of a perpendicular bisector. And the perpendicular bisectors are really special. You might see a question like this. What's the next step if you have to draw an inscribed square in a circle? All you're going to do is draw the perpendicular bisector. So I have a whole like 30 or 40 minute video on EOCMathReview.com that talks about construction. So I know I'm going through constructions in like 45 seconds. Watch the video. You might have already watched it if you're on my Remind, because I do send out Remind videos every day. So you can probably see that. Yay, write a brain break. Everyone take out that white card before you stand up. Okay, so let's take out that white card. I want you to write, we're going to do two things during our brain break. I want you to first, you already mark down what you think you would get if you took the EOC right now. I would like you to please write down what your goal is to earn it. And then I want you to make a commitment to yourself. If you do nothing else, you're going to know more than you did if you didn't come to this session. But imagine what could happen if you actually invested a half an hour each night to help you. Imagine what would happen if you invested an hour a day between now and the EOC. 2 hours a day. Come up and write for yourself. I'm not going to take these from you, but write down what you commit to yourself and then sign your name. What you're going to do during this brain break is, after you've thought about what you're going to do for yourself and what goal you're going to strive for to achieve, I'm going to set the timer, and I need you to come back up to the sign, and underneath that red line, please mark down what grade you're going to shoot for and like really work for to earn. So for example, if right now you think you're going to get a 60, I would have you see for a second average conflict. If you think right now you're going to get a 50, but you're going to really shoot to get that past in 70, I mark it down. If right now you think you're going to get a 70 and you want to shoot for 80 or proficient, write that down. So I'm going to set the timer. We're going to take a 7-minute break. I'm going to give you a 2-minute warning. So stand up, go to the bathroom, write yourself a note, and come up here and mark down on the timeline or the grade line where you have promised yourself you're going to work to. And obviously come back, okay? Oh, if you leave this building, no one is going to let you back in. Okay, I've unmuted the broadcast. I'm gonna keep going and I'm gonna trust that you're gonna stay quiet and we're gonna continue. Okay, here we go. So we're gonna move on and we're gonna keep going. Next, tracing Pythagorean theorem. This is probably gonna be one or two of your questions that you're gonna get when you don't have a calculator. So I am gonna go fast by. So there's two more of my students, and one of them just said that one of the reasons why she got an 80 was because of coming to this. So y'all work hard, you might get that 82. Okay, you might get a 93, you're working so hard. Okay, so this is what we're gonna do. Thank you for that, ladies. Thank you so much for your assistance. I truly appreciate it. Do you want someone to help you push this through now? Okay, I need one person. Ashley, can you help? Thank you very much. Okay, so here we go. Leg, hypotenuse leg. Don't forget, if you don't have an angle noted, you'll not do sine, cosine, and tangent. So in this case, it just says, like, what's the missing sign? You're just gonna do plain old Pythagorean theorem. If they give you a theta or an angle measure, then that's when you're going to end up using sine, cosine, or tangent. I would like all of my students to sit down, please. Okay, you probably heard SOHCAHTOA. Here's the great news. On the formula sheet on the top right, that's where they have sine, cosine, and tangent, and a squared b plus c squared 40, or a squared plus b squared equals c squared. So you don't have to remember these formulas. You just have to remember how to use it. I'm going to show you some questions because this is super important. Oh, sugar shoots, two things. On Sunday at 4 o'clock, I'm going on YouTube Live. So if you are my remind, you're going to get stuff sent to you to sign up. You can participate by watching it. If you subscribe, I think if you subscribe, you can participate in comments, or you can send me questions for remind. So that's Sunday at 4 o'clock. So it's not like we're meeting at school, like you go from home on your cell phone and for remind. So if we don't cover anything here, I'm going to cover it on Sunday during YouTube Live with these orange packets. So make sure you have your orange packets when you go home. Okay? Next. All right, so for the, oh, and please, as you heard me like flip out with some chips on the floor, even if it's not your mess, I still need your help to clean up, because if anything that we don't clean up with like all 80 of us, I have to clean up by myself. And I was already here at 8 o'clock last night. I would prefer not to be here at 8 o'clock today cleaning up after you. So if you can just make sure that you clean up after yourself, that would really help. Just want to make sure I have the mic. Yep. Okay. So let's keep going. So now here we go for trig ratios. Theta is the angle you're talking about. It's what really matters. If you need to find sides, you're going to use the trig ratios. If you need to find the angles, you need to remember to use the inverse ratio. And basically what that means is, you know two of the sides, but you need an angle. And we're going to do some problems like that together. So let's look at our next slide. Everyone see this one? What slide number is this? Y'all see a number? What number is this in your packet? 36? Excellent, thank you, 36. So here's a perfect example of a question they would give you in the beginning of the EOC. The reason why is because you don't need a calculator to solve it. So this could be why. So some of you I see on your phones, I'm not gonna like diss you. I'm just saying you're gonna miss yourself a free question if you stay on your phone. So here it says Ricardo is standing 75 feet away from the base of the building. It says the angle of elevation from the ground is 32 degrees. And it says, what's the height? So let's go over this. And the first question, I'm going to go slow just to make sure you remember. Anytime you see angle, that is my theta. So this is my theta because it's 32 degrees. So that's my theta. Then from theta, I have to mark three things. I mark the opposite, the adjacent, and the hypotenuse. How can I determine what the hypotenuse is? Go for it, shout it. Y'all are brilliant, yeah. It's the longest side, good remembering. So my hypotenuse is gonna be this long line up here. And the way you can tell it's the hypotenuse is it's the side that's not touching the right angle. That's the hypotenuse. Then, when we do the other two sides, I like to do the angle first, or sugar shoots. I like to do the adjacent first because it touches the angle. Adjacent, angle, AA. So this is my angle, this is my theta, so this has to be my adjacent. Angle adjacent. Over here is what's left. This is my angle, this is the opposite. So if we look at us, I'm standing right here, you guys are standing opposite of me. We're not on the same side. These two ladies over here are on the same side with me. You guys are opposite. So the opposite side will never touch the angle. So if I pay attention, okay, what information do I have? Well, here, I have 32 degrees. I have x is the opposite, and I have adjacent is 75. So now I know I have opposite and adjacent. Which trig identity is opposite adjacent? That's not, yes. Is that Christian? All right, that's great. Opposite adjacent, round of applause for Christian. So if you don't know, look down here. Opposite adjacent, there's only one of them that has opposite and adjacent in it. So that's how I know it's going to be tan. So my answer is tan 32. We're going to do another one. Here it tells us this is our angle. Now, they might try to trick you. This is how they're going to trick you. See how they gave you 3 degrees here? They're tricking you by making sure you know alternate interior angles are congruent. So this is 3 degrees, this is 3 degrees over here. That's how they're going to trick you. So this is my theta, here's my adjacent, here's my right angle, so this is my hypotenuse, and this is my opposite, because the opposite always doesn't touch the angle. So when I go back over here, I've got my opposite side, and I've got my hypotenuse. So I say, oh look, opposite, hypotenuse, I must be using sine. So my answer is sine. So far, so good? Next, here's another one. I've got this triangle. It says, what's the best approximation for angle C? Because this says angle C is my theta. Now again, I do. Here's my right angle. This is my hypotenuse. Here's my theta. This is my angle, because the angle, and I'm sorry, that's my adjacent, because the adjacent touches the angle. And this is my opposite. So then, here we have to use our brains a little bit. First, they gave us sine, could either equal 0.923, cos could equal 0.923, or tan could equal 0.923. So this is what you have to do. Well, if it was sine, sine would be opposite hypotenuse, using our trig. So I have to think, well, does 5 over 13, even if I don't have a calculator, does that about equal 1? Well, think of it. What's 6 over 12 equal? A half. Is a half close to 1? Right, but it's not super close. No, because a half is 0.5. So it's not super close, so it's not going to be sine. Cosine says 12 over 13. Well, what is 13 over 13 equal? 1. It's a whole. So could 12 over 13 probably be 0.9? Yes, so that's your answer. If you did tangent, tangent would be 5 over 12, which again would probably give you something around 0.5. Hi, thank you for my 10th graders for being on point and my 11th graders. So that means my answer is cosine because it's closest to 1. Next, here, this is complementary. This is another example of a fundamental trig thing that you should know. How this says A and B are complementary angles, dudes, draw pictures. It's trig, just draw a right triangle. I almost said a wrangle, which makes no sense. Because A and B are complementary, we know that they have to be the acute angles. So it says cosine A is 513. Well, cosine is adjacent hypotenuse. So if it's 5 over 13, I know that 5 has to be my adjacent and 13 has to be my hypotenuse. Sugar shoots. This is 13. This is 5. So it says, what's the value of sine? Well, if sine B is here, this is my opposite, this is my hypotenuse, so it's going to be the same thing. Pretty much the sine of one angle is going to equal the cosine of another. If you're one of my students, I told you something like a boy and a girl are going out and they always have how much money together? 90. So the sine of A equals the cos of B. The sine of 30 equals the cos of 60. Those two angle measures always have to equal 9. Here's another one. We probably will just stop after trig, so that I'll do equations of measurement as the first thing I teach on Sunday. Okay, here we go. We want cosine of A. Here's A. Again, cosine, looking at this formula, is adjacent over hypotenuse. So I'm going to label my hypotenuse first. My adjacent touches my angle because it says A. This has to be my adjacent, which means this is my opposite. So for me to do cosine, I get 9 over 15. Guys, this could be a no calculator question because they're going to expect you know how to reduce. Thank you for telling me 2 people I need to call their parents for. So I know that I need to reduce. What number can go into 9 and 15? 3. So I'm going to divide my numerator and denominator both by 3 and get 3/5. I have a whole video on Pythagorean theorem, so we'll get to that. You can watch that. Here's another example. Here's theta is 75. Here's my right angle, so this is my hypotenuse. This is my adjacent because it touches my angle, and this is my opposite. So I have an opposite and I have a hypotenuse. Opposite hypotenuse is sine. So I know I'm doing sine, so it can't be C or B. And then opposite is x, hypotenuse is 12, so my answer is choice D. Okay, last question that I'm going to show you something online. Next, here is where I told you before, they're going to check you from alternate interior. Here's 54, so here's 54. Let's see what they give us. Well, if this is 54, here's my right angle, so this is my hypotenuse. This is my opposite. So I know I'm using sine, so I can cross off C and D. My opposite is what value? 1200. And my hypotenuse is D. Okay, so let's just do 2 more things. We're going to finish about right on schedule. As a reminder, if you go to EOCMathReview.com, that's going to link you to my YouTube channel. This first video is so important. Please know this video. Watch it as many times as you need. There's yellow papers when you walk out to the A building that have it. It goes right through that and gives you more questions. If you scroll down, it goes kind of in reverse order. This is like basic review, transformations if you needed more help with constructions, need more help with proof, more help with circles, right triangles, volume, density, and modeling, and then probability. Everything you need is there. If you click on my face, you're going to get to the YouTube, the whole channel. Those channels give you even more playlists. So I have even more videos on a particular topic if you need it. So if you want more than just the 45 minutes and you need more than that, that's where you're going to click. The last thing is please sign up for my Remind. It's going to send you reminders and will also give you the link when I go on YouTube Live. So that way you can just click on that and be able to participate. What time is YouTube Live? 4 o'clock on Sunday. 4 o'clock on Sunday. So, there it is. Okay, so that's what you need for that. Yes, sir. The code for Remind is @ Erie. Okay, so please sign up for my remind. It's at Jared. Okay, this is what I need you to do. Do not stand up yet. So part of, who remembers what proud stands for? That's our motto. Who is P? Proactive. What's R? Respectful. What's O? What's A? Are you A? You. And D? Dedicated. You gotta go on that. I need you to be proactive. Don't get up yet. Excellent job, football team. You guys did that. So, be proactive. Study for your test. Don't stay up till 2 o'clock in the morning watching my video the day before your test. Study before. Okay? Be respectful. Clean up the space. Be organized. Unit 5 dedicated. Unit 5. If you see a mess, clean it up even if it's not yours. It's dedicated. Respectfully, please leave the building. You may not stay. And a round of applause to my former students for helping. They are awesome. All right, see you Monday and Tuesday. Great job. Good luck out at EOC tomorrow. You are freshmen. Adios.
Clean up, clean up.